Today we're going to work on graphing equations with two variables. So recall that an equation in the form ax plus b equals 0, where a does not equal 0, is called a linear equation in one variable, because it's got the x. A solution to such an equation is a value of x that makes the equation a true statement. For example, 3x plus 6 equals 0 has a solution of x equals -2. So think about, this is what we've worked on this last couple weeks in this class. Just solving this for x, if you solved it, you'd subtract 6 on both sides. 3x equals -6, and then divide by 3. And that's where the x equals -2 comes from. Because if I plug in -2, that gives me a value that makes this statement true. Today we're going to look at linear equations in two variables, and we're going to focus on graphing them. So, the definition of a linear equation in two variables says, let a, b, and c be real numbers such that a and b are both not 0. So they can be any numbers but 0. Then an equation can be written in the form some number times x plus some number times y gives you a different number, c. This is called a linear equation of two variables. Your x and your y are two variables. I'm taking some number and I'm adding it to some number and I get another number. So let's look at an example. The equation x plus 4 is a linear equation in two variables. A solution to such an equation is an ordered pair x comma y that makes the equation true. So we worked on plotting points on the coordinate plane using x comma y. So you could guess and check and think of what numbers could I add together that'll give me 4. And here's a couple solutions that they give you. If x is 2 and y is 2, 2 plus 2 is 4. X is 1, y is 3, 1 plus 3 is 4. X is 4, y is 0, 4 plus 0 is 4. So there are a lot of combinations. -1 and 5. If you add -1 plus 5, you get 4. There are an infinite number of combinations, so the way we represent this is that we graph it on a line. So if you take a look, for this equation, x plus y equals 4, all these points made it true, so if I plot those points 2, 2, 1, 3, 4, 0, and -1, 5, those all make a line on a graph using the coordinate plane. And that's how you can check if you're doing your problems right. If you don't get a line, something is wrong with the points that you're plugging in. So there's a connection between the equation, the points, and then the line. They all represent the same information, just in different ways. So let's try some examples. For the linear equation 4x minus 5y equals 8, determine whether the ordered pair is a solution. So they're giving us ordered pairs, and they want us to plug it in and see if these points make these true statements. So I'm going to make a little note to myself. Just remember that these are always listed as x comma y. X comma y. So I'm plugging in an x value, and then my y value, and seeing if it's a true statement. So this means it's 4, and I'm putting parentheses just to show that I'm placing it in. Minus 5 times 0 equals 8. Now let's check. 4 times 2 is 8. Minus 5 times 0 is 0. 8 minus 0 is 8, so 8 equals 8. This one's good. Try the next one. 4 times 3 minus 5 times 1 equals 8. 12 minus 5 equals 8. 7 equals 8. This one is not good. So this is not a point on the line. It's not a solution to the equation. Next one, 4 times -2 minus 5 times 5. This gives me -8 minus 25 equals 8. -33 equals 8. That is not good. So the only solution here was the first one. There are multiple other solutions that we could find, but these ones that were given to us, only the first one actually works. So the whole purpose of this is I want you to learn how to look at an equation and be able to figure out if points fit on the equation and then graph those points. So let's find 3 ordered pairs that are solutions to this equation here. And we're going to complete the table to find the corresponding pairs and then graph the line. So I gave you some space down here to be able to work and show your steps. In the table, it's prompting you to solve with certain values. So here it's asking if x is 2, what is y? So we would have to plug in 2 and solve for y. In this problem, it's asking if y is -1, what's your x value? And then again, if x is 0, what's y? So for each one, we plug in the value into our equation that's given to us, and then you solve for the other variable. And this one, I don't know what y is, so I'm going to solve for it. I can drop the parentheses because there's nothing happening there. 2 minus 2y, well, I have to move this 2, so I'm going to subtract 2 on both sides. I have to undo it, so I get -2y equals 6. Divide by -2, y equals -3. So in the table, I can put y equals -3, and I can list that as a coordinate. For the other point, this time it's telling me y is -1, so I'm going to plug in -1 for y. Do my math, 2 negatives make a positive. Solve for x. X equals 6. This one should be a 6. 6. Last one, they're telling me x is 0, so I'm going to plug in 0. Minus 2y equals 8. 0 minus 2y equals 8. I didn't do anything with that parentheses, it just goes away. 0 minus anything is that number it's again, so it's just -2y equals 8. Divide by -2, y equals -4. So now I can plot these points onto the coordinate system. So I've got 2, -3, 6, -1, and 0, -4. And if you do this right, you'll see that you're able to draw a line through those points. What this line represents is that every point that's on this line is going to be a solution to this statement. So any x and y coordinate that I can pick that would be on this line would be on this, be a solution to this graph. Okay, let's do 2 more examples, and then I'll let you work on some practice problems on your own. So same idea, here's an equation. Complete the table, and I gave you some space to do the work, and then graph it to make sure your answer is correct. So in this case, x is 2, so I'm going to plug in 2. 4 plus y equals 6. If I subtract 4, y equals 2. This time y is 6, so 2x plus 6 equals 6. Nothing's happening with that parentheses. Subtract 6. 2x equals 0. Divide by 2. X equals 0. X is 3. So 2 times 3 plus y equals 6. 6 plus y equals 6. Y equals 0. Plot your points. 2, 2, 0, 6, and 3, 0. And again, you can see that there's a nice line being formed between those points. Okay, the last one. The equation's written a little bit differently, but we can still use our table and graph to make sure we're doing it correctly. So this is the equation y equals -1/3 x plus 1. So I'm just going to plug in these values for x and see what comes out for y. So it's y equals -1/3 x times -3, which I'm pulling right from the table, plus 1. So y equals -1/3 times -3. Let me show you on your calculator. If I put -1/3 in parentheses and multiply it by -3, you get +1. So 1 plus 1, y equals 2. For the next one, y equals -1/3 x, or times 0. So x is 0. Anything times 0 is 0, so this just becomes 0 plus 1, or 1. And then the last one, we're plugging in 3. Again, to do the -1/3, to type it in, times 3, you get -1 this time. -1 plus 1 is 0. So let's plot those points. -3, 2, 0, 1, and 3, 0. And then you can draw your line through your points. Okay, try the practice problems with these. You'll be given an equation, you got to fill in the table, and you can use the spaces available to graph. Good luck.